So the first thing we're going to do is find out the IP address of Necromancer, since we're unable to log into Necromancer right now. So we're going to first determine the IP address of our own machine, as seen here. This is our IP address. So now we have to find out the IP address of Necromancer. We can do this by doing an ARP scan, which will send out ARP packets to the network to see which machines and devices are connected and able to respond to the packets. So the first two right here belong to my host and our gateway, and the last one here is a broadcast address. Therefore, this one right here must belong to Necromancer. So now that we know the IP address of the Necromancer machine, we can do a bit of reconnaissance to determine the open ports on it. So first we're going to determine if there's any available TCP ports that we can access through. So we're going to use the tool mmap, and we're going to use these kind of flags. We're going to use a stealth scan, which is the most common flag used. We're going to use this flag to skip any ping requests and just do the scans right away, since we already know that the host is up. We're going to make the intensity 4 just to make the scans a little bit faster. This part is totally optional, but I like to do it because it makes the scans come by faster. We're going to set the port range from 1 through 65535 just to maximize the amount of ports we can scan on the target. I'm going to set its IP address. Now this will usually take around a couple minutes, and if you want to check the status you can do Control L. After about a minute or two you can do it again. It will tell you the progress of how much time is left for the scan. So for me it'll take about 23 minutes. So I'll take a pause right here and we'll come back when the scan is complete. So we're back from the scan, and as we can see, all the ports were filtered, which means we can't access through them remotely at the moment. So instead of scanning for TCP ports, we're going to try a different approach. We're going to scan for UDP ports and see if there's any available. So we're going to use instead the flag U to specify UDP ports, and we're going to give it the same range for ports as before. And this too will take a little bit of time because of the amount of ports we're scanning. So I'll pause the video right here and we'll come back once the scan is complete. So now that the mmap scan is complete, we can see that one port, UDP port 666, is actually open on Necromancer. So we're going to attempt to access it using netcat. So we're going to use the command netcat, specify the port to be UDP, set the target IP address, and specify port 666. So as seen here, nothing's really happening, and when I first did this lab I thought this would have been some sort of network issue since the port was open but nothing was happening through the connection. So I decided to check out Wireshark to see where on the network the packets were being dropped. So I open up Wireshark, and I began capturing on ETH0. There you go. Okay, we'll stop right here. Stop capturing, and we'll stop the netcat connection here. So as we can see here, I didn't find anything related to my outbound connection to using netcat, but what I did discover is that the Necromancer VM was sending out a flood of packets onto port 444 for some strange reason. And this was odd because before, when we did the first initial scan, port 444 was not open. So perhaps now it has opened up. So what we're going to do is, instead of port 666, we're going to do netcat on port 444. We're going to listen for any incoming ports from 4444 from the Necromancer VM. There you go. That took a little bit more time than I expected, but now we can see that we got some sort of output, and it looks to be a wall of string. And from the looks of it, it looks like base 64 format. So we're going to need to decipher this in order to get some sort of coherent message. So what I did was went online and found a base 64 decode. I went to this URL right here on the top and I pasted it in here to decode. And there you go. We got a more coherent message. It is pretty cryptic and pretty spooky, but if we scroll down here, we get our very first flag right over here. And the next clue for us to get the second flag. So now that we got the first flag, the next step is to follow the advice of the clue. It says here, what we got to do is chant the string of flag 1-U666. What does that mean? When I first thought of this, I thought, perhaps chant means echo, and we have to echo it into port 666 on Necromancer. So that's exactly what I did. I first copied the exact string, or the exact string of the flag right here, into an echo command. And then pipelined it with a netcat command. I'm going to specify again UDP port. And we're going to specify 666. So here it says the chant had no effect, try it in a different tongue. So I thought to myself, what other tongue do they mean? And then I realized the flag perhaps could be in a different format. So when I tried replacing it here, seeing if it was base 64, it gave me some incoherent mess. So it was not that. So then I thought to myself, maybe it could be MD5 hash. So we went to MD5 decoder. You can't really decode MD5s, but there is an online database for already cracked MD5 hashes. So that's exactly what we're going to do. We're going to go on one of these decoders. We're going to put in the flag string. We're going to do a quick decryption. And right here, we get the string open sesame. Perfect. So that's what we're going to use instead. Same command. We're going to do echo. We're going to paste our new string in sesame. And then we're going to pipeline it with a netcat command. There you go. We got it. We escaped and we got the second flag right here. So we can go ahead and copy that to your table. And we got the next clue right around here. There you go. So the next clue to get the third flag says that we have to look out for the numeral 80, and that brings in mind port 80, so Apache, which must mean that it is now open and we can access it now. So I first wanted to see what the website held. So I went on the IP address, port 80. And as you can see here, there's some more cryptic text and an image. First, this didn't really give me much. I tried inspecting the source code to see if there's anything hidden, but this gave me really nothing. I then decided perhaps the image itself could contain something valuable. So I saved the image, basically copied it to my desktop. And as you can see, it's right there. So we're going to escape this. Now, what we can use is a tool called binwalk, which checks for any embedded files or string in a JPEG or in any other kind of image. So we're going to use the tool binwalk, and we're going to first just do pile of feathers. So we can see here, within the image, there's actually a text file called feathers.txt. So how do we get that file out of there? How do we extract it? Well, binwalk has a option to extract that right over here, extract -e. That's the flag we're going to use to extract that file. So we're going to use binwalk -e pile of feathers. and it'll extract everything that's inside that image. There you go. So we're going to open it up to see what's inside, and we got some cryptic message right here. We're going to try and decode that again. So we're going to go MD5, see if it's an MD5 hash. Unfortunately, this is not the case. So we're going to try space 64. And there you go. Flag 3 is found right over here. So over here it tells us to cross the chasm at this subpage. So what we're going to do is copy it. We're going to go back to the chasm, which is our Apache web page. I'm going to post it at the end right here. So we get a new page with a black background, an image of a magic book, and some text. I tried inspecting the source code, but nothing came up interesting. I also tried downloading the image magicbook.jpg and using binwalk on it to see if there's anything embedded, but nothing came up. So I was a little stumped. But then I read the last line over here where it says there must be a magical item that could protect you from the Necromancer spell. So that gave me the clue or the idea that perhaps this magical item is the name of another subdirectory found on the Apache webpage. And that's how we can continue. So in order to find out, we're going to try and brute force it to see what kind of magical item it is. So what we're going to do is find a list of magical items or occult terminology that can aid us. So we're going to look up for a list of occult terms. We're going to find one on Wikipedia. What we're going to do is just copy everything from start to bottom. Over here, we're going to copy it. We're going to create the list of magical items for us to brute force the page with. So we're going to call it occult items.txt. You can call it whatever you want. We're going to press I to enter, and we're going to paste the selection. Now, for this to work, we got to make sure that all the text is lowercase, and we get rid of anything that's not a terminology, which includes headers like these, and also any kind of description on the side like this, Chaos Magic. So one simple trick you can do to lowercase everything in Vim text editor is by doing this. You're going to press GG twice. You're going to do capital V to enter visual mode. You're going to do capital G to highlight everything, and finally you're going to press lowercase u to lowercase everything. And there you go. You're going to delete everything that's not a terminology, including those headers, spaces, and descriptions on the side. You should also try to get rid of, all those spaces before the text right over here. So I'm going to let you guys do that by yourselves, and we'll come back to you in a second. So as we can see here, we've fixed up the file. So now there shouldn't be any issues when we use occult items.txt to use the brute force. So we're going to save and quit. We're going to use the tool GoBuster to perform the brute force attack on the web service. So we're going to specify we're looking for directories and files under this web page. We're going to specify the URL to be here. We're going to copy that, paste selection. We're going to specify the word list that we're going to be using to be occult items.txt. As we can see, there is one hidden file or directory called talisman. So we're actually going to copy that. We're going to paste it right here. And it seems to be a file. So we're going to download it. And we're going to move that to our desktop. Now it seems to be, from according to properties, some sort of executable file. So we're first going to try to see the functions and strings found inside this executable first, before we try to run it, try to reverse engineer. So for this, we can use the tool called readelf, and we're going to specify that we're looking for all strings and functions and variables and things like that for this executable, and we're going to specify that we're looking for talisman. Now, since there's a whole lot that we're looking for, what I'm going to just look for specifically is functions. See what is calling what, how this program is working exactly. So we're going to do grep func. There you go. So there's a couple of functions that are being called here, but the one that I find most interesting is chant to break the spell and wear talisman. So now that we know the functions, we kind of have an idea what's going to happen. But first, let's try running it. So we're going to do gdb talisman. There you go. So first things first, we're going to try to see if we can set a breakpoint at the main function. So let's try running it. Oh, my bad. So let me just quit first. There is a permission denied error. So first what we gotta do is give it permissions. So we could do chmod, for example, 777. So this, since this is recursive, to talisman. There you go. That should work now. So let's try that again. First, let's see actually what it's going to do on its lonesome before we do any breakpoints. So we're going to run it. It says, do you want to wear the talisman? Let's say sure. Nothing happens. Well, that's to be expected. Let's do it again. What if we said no? Nothing happens. Okay, so let's try instead to set a breakpoint at main. Now, from what I recall from the functions, it appears that if the user tries to put any kind of string, it will automatically jump to the function where talisman. Okay, so let's try making a breakpoint in main and running it. So it stopped. It didn't even prompt us yet. So since it didn't prompt us with a user input and therefore go to where talisman function, we're going to try and see if we can jump to the chant one. So we're going to say jump to chant to break spell. Yep. So we're going to press enter. And there you go. We got the fourth flag right here. So now we got the fourth flag. The next hint tells us to chant the words at U31337. So just like flag 2, it's just telling us to echo the results of the flag into port 31337 using netcat. So we're going to copy the text here. This is the flag. We're going to put it into the MD5 decryptor. And it'll give us back black magic. Next, we're going to quit GDB, and we're going to echo the results. Paste selection, pipeline it with netcat. We're going to specify UDP port, target address, and 31337. There you go. You got more text and the fifth flag. So the next hint tells us to go to this subpage right here. So we're going to just copy that, go back to the cave, and we're going to change the page address to be this one. And there you go. Easily flag sync us at the top. So this will do it for the first part of the video. We've covered 6 flags. Part 2 will cover flags 7 to 11, and that should complete the Necromancer lab. So thank you for watching, and go check out part 2 to continue.